This is an example of using AI or a large language model in a way that is environmentally aware. I am going to go ahead and kick off this process and talk about it while it is running. So, more or less, what this does is it runs a function called run summarization, and this takes a single argument, which is just a path to a PDF file, more or less. And what this does is this will do some formatting to that document. A lot of summarization works the best when using LLMs when you do some pre-processing to the data to get it in what's called Markdown. There are other formats that you can use. Markdown basically certain parts of the document and adding hints to, hey, this is a section header, or this is a table, or this is a bulleted list, that type of thing. And then this uses Ollama, which is a way that you can run large language models on more commodity hardware using an open source, pretty small 2 billion parameter model, and then basically passes that document to this summarization engine. And there's some configurations I have set to get this to run in a decent amount of time. There's definitely some more optimizations that we could do on this. And then lastly, we want a nice looking output so we can format this document to look decent in Word format as well. And then one of the other interesting things that we do is that we add emissions tracking on this. So for those familiar with Python, this is called a context manager. So we can wrap this execution in a context manager, and then this will automatically append a row every time this process runs to emissions.csv, and then we can print out the emissions report and do some tracking over time on this. So again, this is just kind of a minimally viable product, if you will. What we would want to do in production is obviously wrap this in some type of a interface that is a little bit more user-friendly, but this is just kind of what the back end looks like. And back to the emissions tracking, this uses a library called Code Carbon, which is pretty nifty. So we can see that this process completed, and then this particular execution has happened 3 times. So we can then kind of see how much CPU power was used, how much RAM was used, what was the energy that was consumed. I need to look at the documentation a little bit more to figure out exactly the units and make this a little bit more interpretable. This also does some things with water tracking as well. I'm guessing some things kind of get rounded down to 0. In certain cases, yeah, water consumed is 0. I'm guessing that's getting ramped or rounded down. But there are lots of things that we can do with this, but we can actually get kind of an emissions report on all of these runs. And this last row is what I just ran. And then we can look at what the output looked like as well. So that will give us summary.docx. I'm on a Mac, so this is going to open it up in Pages. So yeah, we get this nice looking report that's formatted, and I have not verified the accuracy of this summary. That would be something else to do on this, but essentially what happened was the program took this PDF, converted this to a more readable format, ran it through a local large language model to produce summary.docx, and then did emissions tracking along the way, and then produced this nice output to tell us about how much energy this was used. So yeah, this is just kind of a way that we can start to think about being environmentally aware and conscious when using AI and large language model applications.